Good morning. Today we're going to see a problem in rectilinear motion. Determine the time required for a car to travel 1 kilometer along a road. The car starts from rest and reaches the maximum speed at some intermediate point, then stops at the end of the road. The car can accelerate or decelerate at 1.5 meter per second square. They are given the question. First, we have to understand what they have given. The car travels for a distance of 1 kilometer. Between this 1 kilometer, two different scenarios happen. One, it starts from rest and reaches the maximum speed. After reaching the maximum speed, then the car slows down and it stops at the end point. So these are the two different scenarios that happen during the distance traveled at 1 kilo for a distance of 1 kilometer. So we have to draw a diagram. So this was the diagram that I drawn to explain this problem. So let us assume the car travels to reach the maximum speed. Let it be here. From the maximum speed to the destinations where it stops, it is here. Since it is given that the car accelerate at or decelerate at 1.5 meter per second square, so the distance traveled by the car will be equal on both the sides. So the S1 plus S2 is equal to 1000 kilometer. In that case, S1 will be of 500 meter, S2 will be of 500 meter. This is our assumption. It might be right. Since the acceleration is 1.5 meter per second square, it is uniform on for acceleration, decelerations. So the distance travel will be uniform. Let us write the given data. The acceleration is 1.5 meter per second square. The initial velocity for the stage 1 will be 0. And the final velocity for the stage 2 will be 0. So V is equal to V max, that is maximum velocity attained to reach. So we have to substitute in this formula. V is equal to U plus AT. Here, as I said that V is equal to V max and it starts from the rest, U is equal to 0 and acceleration 1.5. So therefore T1 is equal to V max divided by 1.5. So S is equal to UT plus half AT square. Here we have to substitute the T1 value, that is V max by 1.5. By substituting that value, we'll get the S1 as 0.75 V max by 1.5 square. Because the UT, initial velocity U will be 0, this entire term will become 0 here. So we have to take this side, and by solving this, we'll get 0.75 V max by 1.5 square. Now we have to take the second stage. In the second stage, the initial velocity U will be equivalent to V max. The final velocity V is 0. It decelerates at 1.5 meter per second square. Here let the time be T2. By substituting all the values, that is in the equation V is equal to U plus AT, we get the T2 value as V max by 1.5. So we can substitute the same in the equation. S is equal to S2 is equal to UT plus half AT square. We'll get the equation as S2 is equal to V max square by 1.5 square minus 0.75 V max by 1.5 the whole square. Then we have to solve the equation, that is total displacement is of 1000 meter, that is 1 kilometer. So the total displacement, to find the total displacement, we have to add S1 plus S2. When we add the S1 plus S2, these are the S1 and S2 that we have identified, we will get V square max by 1.5. So the V max value will be 38.73 meter per second. By substituting all this, we'll get the V max value as 38.73 meter per second. So they asked for the total time to reach that particular destinations. So the total time, we have identified T is equal to, T1 is equal to V max by 1.5 and T2 also V max by 1.5. So T is equal to 38.73 divided by 1.5 plus 38.73 divided by 1.5. We'll get the T value as 51.64 seconds. If we want to calculate the S1 value, we can substitute the values that we have identified in the any one of above equation. Just check this equation. Any one of this equation, and we can find the value of S2. We'll get the S2 value as 500 meter. Then we substitute the Vmax value. We get the S2 value as 500 meter. Similarly, the S1 value will be 500 meter. Since S1 plus S2 is equal to 1000, we get the S2 value as 500 meter. We'll get the S1 value also 500 meter. So the answers which we have identified is given here. We can add S1 value also, S1 and S2 value here. And this is the standard procedure to solve the problem. Thank you.